So here we go with lesson 7.4. This will be the last lesson of part 1 of chapter 7. So lessons 7.1 through 7.4 make up part 1. And this is the last new information you'll learn before we do our test. And so up to this point, think about where we've been. We have added and subtracted polynomials. We've multiplied polynomials. And we've multiplied special cases of polynomials. What we have yet to do, though, is have a final answer for the value of x. And so today we're going to be looking at equations that must result in an answer of 0. And our goal then will be to figure out, well, what does the value of x have to be for the equation to equal 0? And so the first thing we're going to do is we're going to look at if we plug in this number right here, 5 for x, does it make this equation 0? Or if we plug in -3 for x, does it make this equation 0? Well, one of the first things we have to understand is that we are multiplying two binomials, but each of these binomials is a factor. So you can think of this as factor 1. So x minus 5 is factor 1. And then x plus 3 is factor 2. Now, if I already know the result to my multiplication problem is 0, think back to when you first learned your multiplication tables. You learned a rule that said anything times 0 is 0. So if I have these two factors, if I can make either one of them 0, then it doesn't even matter what the other one is because it's going to be multiplied by 0 and the result's going to be 0. So the first thing we're going to do is we're going to plug in 5 here and here. And it'll look like the following. So the first binomial becomes 5 minus 5. And the second binomial becomes 5 plus 3. And it's still set equal to 0. Well, what happens in this first factor? 5 minus 5 is 0. The second factor, 5 plus 3, is 8. But that doesn't really matter. What I'm focusing on is this. If I can get either one of the factors to equal 0, I know the whole thing must equal 0. Because 0 times 8 is in fact 0. So this would mean that when I plugged in 5, when 5 was x, this did result in a true equation. So we can say that 5 is a solution. 5 is a solution. So I'm going to do this in blue to let us know that that did work. And now we're going to do the same thing for -3. Same two binomials, but now I'm replacing this x and this x with -3. So this is going to look like this. -3 minus 5 times -3 plus 3. So that's the equation. Same as what we started with, I'm just replacing x with the value, -3 and -3. In the first binomial, -3 minus 5 is -8. -3 plus 3 is 0. And there's my magic 0. So because one of the factors is 0, and anything times 0 is 0, well, I know that -8 times 0 is 0, which means that x being -3 was also a solution. So there are two different numbers that actually make the solution true. So that's what we're going to be focusing on today, is what are the values of x that make the equation true. And all of our equations are going to be set equal to 0. So the goal is to get one of the factors to be equal to 0. Okay. So now it says, what do we think the solutions will be for this equation? How do you think we could find the solutions? Well, if our goal is to just make either one of the factors 0, I can take them individually. I can start with x plus 4. So I'm trying to say x plus 4 equals 0. Now how do I solve this for x? Well, I need to move the 4. The 4 is positive, so I subtract it on both sides. And that puts me at x equals -4. So I know when -4 is here, it makes this factor 0. So that's one of my solutions. The other solution comes from the other binomial. Now I'm saying x minus 7 is equal to 0. And I would add 7 to both sides. And x equals 7. So that's my second solution. Just like up here, both 5 and negative 3 worked. Down here, I know that the number that makes the first factor 0 is negative 4. The number that made the second factor 0 was 7. Now we're going to look at some vocabulary. So factored form. We've already seen two examples of it. X plus 4 times x minus 7. These are factors. One factor times the second factor. Well, what this really means is we're taking a quadratic polynomial and writing it as two factors. And then those two factors get multiplied by each other. And what that leads to is our zero product property, which again, this kind of goes back to that rule that you learned a long time ago. If either number in a product is 0, then the product is 0. And we saw that. If we make this binomial 0, it doesn't even matter what this one is. Anything times 0 is 0. If we made this binomial a total value of 0, it doesn't even matter what this one is, because anything times 0 is 0. It's called the zero product property. And so the solutions, like what we have here, they are the values of x that make the equation true. And the roots are actually the same as solutions. The roots of a quadratic or the roots of an equation are the answers that make it equal to 0. And then repeated roots are when the solution occurs more than one time. And you'll see some examples of that in just a second. But when they occur more than one time, so when the same number can be put in two different parentheses to make them 0, that solution is recurring more than one time. That's called repeated roots. So now we move on to the back page. And what we're looking at here is we're looking at one item being multiplied by another. So this would be a monomial multiplied by a binomial. But notice that it has to be equal to 0. So this first monomial right here, which is just x, that would be factor number 1. That's this right here. And then factor number 2 is the binomial. Well, again, if I can make either one of these factors equal to 0, it counts as a solution. Well, when you have a variable on the outside, this works out very nicely for us. Because if this factor right here is 0, well, that 0 times all of this is going to equal 0. So the one on the outside, I know x is already 0. That's one of my solutions. Then on the inside, I'm saying, okay, well, what number will make all of this equal to 0? What number plus 5 equals 0? Well, it's just its opposite. What's the opposite of positive 5? Negative 5. So that's my second solution. Both of these, if you plug them in for x, make the equation equal to 0. If I make this 0 and 0, I would have 0 times 0 plus 5. Well, that's 0 times 5, which equals 0. And if I plug this negative 5 in for both x's, that would be negative 5 times negative 5 plus 5. Well, the negative 5 plus 5 is 0. So 0 times negative 5 does in fact equal 0. So I know both of those solutions work. And we're going to follow a similar pattern here on the next couple of questions. So on number 2, I know that if this p is 0, 0 times 5 is 0, and times anything else that exists, as long as I'm multiplying, is 0. So I know one solution is p is 0. Now think, what value of p makes all this binomial equal to 0? Well, it's just the opposite of what is already there. So if this is minus 2, this has to be positive 2. So I know it has to be 2. So my two solutions, and this is how we'll start writing our final answer, we'll separate our solutions with commas. When p is 0 or 2, it makes this whole equation equal to 0. On number 3, I know that on the outside factor, a can be 0. On the inside factor, if a is 12, then 12 minus 12 equals 0. So 12 is my other solution. Now we have a binomial times a binomial. These are like what we saw on the first page. Well, just think to yourself, what value of c makes this factor equal to 0? And then what value of c makes this factor equal to 0? Well, for this one, if c is 2, it makes this binomial 0. And over here, if c is negative 1, it makes that binomial 0. Those are my two solutions. Number 5 has just a little bit more work because we're saying, well, what makes this first binomial equal to 0? And then what makes this second binomial equal to 0? And I'm just going to do some quick algebra. Subtract 5, and I'm at 2a equals negative 5. Divide by 2, divide by 2. And now I know that a is equal to negative 5 halves. And I'll write that in a second when I have more room over here. I'm going to solve this one. I'm going to go plus 5, and I have 2a equals 5. Divide by 2, divide by 2. So my final two answers were when a is negative 5 over 2 and when a is positive 5 over 2. So both of those numbers work. One of them makes this binomial 0, the other one makes this binomial 0. And then for number 6, well, this one's pretty easy like number 4 was. I know that when w is negative 10, it makes this factor 0, and when w is 13, it makes that factor 0. Number 7, we have x minus 3 being multiplied by itself. So I expand this, and now both of these are saying the same thing, which means there's only going to be one answer. There's only one number that makes this binomial 0. That same number is also what makes this 0. So I know for this binomial, x is 3, and for this binomial, x is also 3. And we are going to get in the habit of writing both of them. That's going to become more important later in the chapter and also for chapter 8. So then for this one over here, I expand it. I have 2x minus 1 times 2x minus 1 equals 0. And if you solve these individually, what ends up happening is x is going to equal 1/2 for both of them. I'm going to show you a shortcut. Watch this. Over here, I knew that this could be 3, and I was only working with whole numbers. Well, here, this one's a little different, right? I can't just put a whole number here because I'm not sure if that's going to work. Well, watch this shortcut. Put the second number, which is negative 1, over the first number and change the sign. So instead of negative 1 over 2, I change the sign, it becomes 1 over 2. So again, put the second number, I'll do off to the side here, the second number over the first, so negative 1 over the 2, but then change the sign, so this negative becomes a positive, and there's your answer. Now, you could do it just like we did up here. This is the longer way. The shortcut, again, put the second number with the sign over the first number, but then change the sign. Okay, and we'll do that again down here when we get to number 10. All right, a couple more. On number 9, we actually end up with 3 binomials, because w plus 4 squared means w plus 4 times itself, and then I also have the w plus 1. But now look at each binomial. What's the value of w that will make them equal to 0? Well, for this one, it's negative 4. I get the same answer for this one, negative 4. It's what makes it 0. And then negative 1 right there. And that's all you have to do. So this is the first time we've actually seen 3 solutions. We're also going to see 3 solutions here. So g equals 0 is a solution. But now look at these ones. These are actually written opposite. Okay? So I can think of it as negative 3g plus 6 and 3g plus 6 like that. And now I can put first number over second number, 6 over negative 3, but change the sign. So it becomes 6 over 3, which is 2. And then this 6 over this 3, change the sign, becomes negative 2. So once again, we have 3 solutions. All right, Have fun with the assignment. See you next time.